8270 is the EPA mandated test for semi-volatiles. The EPA 8270 is an analysis for materials which are extractable by methylene chloride. The initial step is add methylene chloride, extract into the methylene chloride, pour the methylene chloride off, add more methylene chloride, extract, pour it off, add more methylene chloride, extract, and pour it off. So the first stage of the 8270 results in a rather large container of methylene chloride, like 100 to 200, even 300 milliliters of methylene chloride, with very small amounts of whatever it is you're looking for. So the first step is, what are we going to do with all this methylene chloride? It's like 99.9999% methylene chloride, and what you're looking for is kind of buried in all that methylene chloride. The key to the condensation, the key to the concentration, lies in the boiling points of the materials you're looking at. The semi-volatile is called the semi-volatile. The 8270 is called the semi-volatile GC mass spec. Its semi-volatiles are things that they boil, they will turn into gas, but typically at 100 to 300 degrees, 100 to 250 degrees centigrade. So a simple guess would be that if you took the methylene chloride, which has a boiling point of about 40, and heated it up to 40, the methylene chloride would come to a gentle bubble, 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 and the methylene chloride would boil off, leaving behind everything else. The way it's done in real life is not real different than that. You essentially boil it gently. The methylene chloride very quickly boils off, and the other materials don't. The complication is that, again, let's take naphthalene, has a boiling point of 218 degrees centigrade. So it doesn't boil very easily at all. It dissolves nicely in methylene chloride. So the methylene chloride is bubbling off. Naphthalene comes to the surface. Naphthalene doesn't boil anywhere close to 40 degrees centigrade, but it will evaporate. And the reality is that if you just blindly heat the methylene chloride will boil off nicely, but you're going to lose a lot of your semi-volatiles. The actual chemistry, the actual physical science behind cleanly separating the methylene chloride from other things is a complicated chemical engineering problem, petroleum engineering problem. Petroleum engineers and chemical engineers are experts at this, and maybe one will come along and help us out with this. But in the meantime, the world of environmental science, we're little chemists, and we're trying to meet objectives. We got things we're trying to do, and we don't care too much about how it gets done. There's a trick which we use. It's called the Danish Condenser. The Danish Condenser consists of 3 pieces of glassware. The first one, or let me say the middle one, is a glass vial. It looks like a separatory funnel. It's not, but it looks a little bit like one. It's kind of conical at the bottom and pointed at the top. It has 2 ground glass fittings, one at the top, one at the bottom. The ground glass fitting at the top goes into a Snyder column. The Snyder column, it's kind of a low-tech kind of thing. It's not exactly a condenser. It's more like a filter or a separator or something like that. But it isn't complicated. All it is a tube. The tube has indentations, and those indentations trap 3 little balls. The balls are trapped in the indentations, and they rattle around in the Snyder column. They come in different sizes. A typical Snyder column is maybe about this long. The flask is maybe about this big. And then at the bottom of this conical flask is a little graduated cylinder. And I say little, I mean it's pretty small, like maybe 10 mils altogether, maybe 20 mils altogether, but it's graduated. The bottom column is put into the top column. The methylene chloride is poured into the whole thing. And then the Snyder column is put on. Sometimes they're held together with springs. Sometimes not. And then this whole thing is put in a steam bath. The steam bath heats the methylene chloride up well above its boiling point, and the methylene chloride starts screaming out of the flask going into the Snyder column. When it reaches the Snyder column is relatively cool. You know, it's like maybe, I don't know, 50 degrees centigrade or something like that. It's a little bit cool. The methylene chloride fights its way through these little balls. The Snyder column kind of filters only the methylene chloride, and things that are very volatile are able to fight their way through the column and get out and completely escape. Everything else kind of gets stuck in the balls. It kind of sticks to the balls. And the balls, of course, the whole thing is coated with methylene chloride, but the vapors are able to fight their way through and escape into the air. This is done on a steam table in a hood. The methylene chloride is moderately toxic, so it's not something you want to breathe. It's the people that do this are specialized in this. So let's kind of run it as a scenario. You have the tube, the little tube, the bigger flask, and then the Snyder column. It's full of methylene chloride. The methylene chloride is fairly clear. Hopefully it's clear, but sometimes it's not. And you put it in a ring stand in the steam bath. The steam bath heats it up. It starts bubbling. It starts bubbling. It starts bubbling fairly quickly. I'd say like within 3/4 of an hour, something like that. The methylene chloride is really starting to get pretty much gone. And as the methylene chloride goes down and down and down, the operator, using a water bottle with methylene chloride in it, it says methylene chloride on the water bottle, squirts into the Snyder column. The methylene chloride percolates through the Snyder column, washing anything that's in the column down into the flask. It has to be evaporated again. Everything you add has to be evaporated. And then as it goes down and down and down and down and down, the operator gently washes it down, and as it goes down below the big column and goes into the graduated part, the operator makes one last rinse, quickly takes it apart, takes the big flask away, puts the Snyder column right onto the graduated cylinder part, and keeps going, carefully washing it, carefully watching it, carefully washing and watching and evaporating it, washing and evaporating it. And as soon as the liquid gets down to exactly 1 milliliter, there's a mark on the graduated cylinder. As soon as it gets down to 1 milliliter, the operator, the technician, takes a Pasteur pipette, disposable pipette, draws it off, puts it in a labeled autosampler vial, one of these little tiny vials, puts it in a labeled autosampler vial. Those vials hold about 1.5 milliliters or something like that, so it pretty well fills it. And then crimp seals it, and that's it, and he's done. And then it goes to the operator. The glassware is cleaned, yeah. It's cleaned. Is it scrubbed? Yeah. The glassware is put in a furnace and heated up to about maybe 800 degrees, and the furnace burns off all the organic material. So it's cleaned and scrubbed and all that kind of stuff, but not really. It's actually put in a furnace and burned down to nothing. It's gone. You know, it's not clean. It's like sterilized of organic material. The Danish concentrator, which is the 3 pieces of glassware, they cost about, I want to say, $150 to $300. They're pretty expensive. They last a long time if you're careful with them. The 8270 involves a complicated extraction. The extraction in the condensation, let's look at this for the time real quickly. 3 samples come in from the Walmart site. They want to build a Walmart. The consultants say we need an 8270 from this spot, and this spot. The lab gets 3 samples for 8270. The technician is going to do 6 samples. A blank. I think it's intuitively obvious that you need to check and make sure that your equipment is clean. The 3 samples, and then a spike sample, which is a quality control sample, and another spike sample, which is another quality control sample. So the prep is typically, for 3 samples, there would be 6 preparations. So 6 extractions, 6 condensations. The initial extraction will take the technician all morning. The condensation step will take the technician all morning. And then these 6 samples will go to the instrumentation people. The instrumentation is actually the area that I worked in. The instrumentation people, it'll take them, it's essentially all day. Not all day continuously, but it'll take like, an 8-hour shift pretty much to set these up, run them, and process the data. I think the financial aspects are interesting. A typical 8270 costs $600. You want to have an 8270 run on your garden soil, not a problem, but it'll cost you $600. It's negotiable, but it's kind of a big bucks deal.